Hello friends, today in this video I am going to show you all required steps for the spur gear and helical gear numerical. So first of all, first step, determine the gear tooth profile. In these steps we have to determine what type of gear tooth profile we are going to use. It will given us in a numerical, or we have to assume it. There are three types of gear tooth profile. First, 14-degree full depth involute involute profile. Second is 20-degree full depth involute profile. And third is 20-degree full depth involute stub tooth profile. These are the three types of tooth profiles which are given in PhD data book. You can select any one of these and solve the numerical, or I also recommend 20-degree full depth involute profile tooth for the solving numerical, which is easy to solve by using this gear tooth profile. Now move on to second step. In second step we have to determine what are the number of teeth on gear component and pinion component. So if we have given number of teeth on gear and pinion on numerical, or we have to assume that the pinion has a 18 tooth, which is denoted by ZP, denotes the gear tooth on pinion, and ZG denotes the gear tooth on the gear. So by using a formula of reductant ratio, we have to calculate the gear tooth of on gear using I is equal to ZG divided by ZP. Using this formula we can calculate the ZG, which is the gear tooth profile, and if we want to find I, for I we have to use input speed divided by output speed, which is given in example. Now move on to third step. We have to select the material for the gear component and pinion component. You can select both components from PhD data book, page number 1.9, where given many types of steel materials. You can select there from there, or we have to take their values, such as tensile tensile strength, yield stress, and BHN, also known as Brinell hardness, for those materials for both pinion and gear. Next, we have to determine which is the weaker element. For in our step number 4, we have to determine which is the weaker element. It will be pinion or gear. If material for both components are same, then there always pinion is weaker element. If material for both elements, pinion and gear, are same, then the pinion is always weaker element. If we have if both components have different materials, we have to calculate their bending stress, which is given on a PSG databook page number 8.16, which is a sigma b of KCl divided by n into K sigma into sigma minus 1. We have to calculate both gear as well as for pinion. By calculating that, we have to determine which is the weaker element. If gear is weaker, we have to consider that the design is based on gear. If pinion is weaker, we have to consider that the design is based on pinion, and we have to neglect all the values for the strong element. Now, in step 5, we have to calculate module for the weaker element. By calculating module, we get the module and we have to select the preferred series module from PSG databook 8.2. PSG databook. From this page number, we can get the preferred series module from calculated module. In step number 6, we have to calculate dynamic load, which are the objective of our numerical. We have to find the dynamic load and wear load. For in step 6, we find the dynamic load. In dynamic load, which is the formula given on the page number 8.51, by using that formula we can easily calculate the dynamic load. In step number 7, we have to calculate contact stresses, which are the given in page number 8.18, and their values are given in page number 8.19 and 20. Last step, we have to calculate the wear load, which is the formula given on the same page number 8.51. These are the all 8 steps required for the solving the spur gear numerical and helical gear numerical. You can use this all 8 steps one by one to solve those numerical easily without any mistakes. Thank you.